For this next example, we're looking at the integral from -3 to 3 of 1 over x dx. So it's the same function, the same integrand as before. And this time, though, the bounds are different. -3 to 3. And like initially, we're thinking, okay, well, those are bounds that we're used to seeing, something like that. We've done that in previous definite integrals. But the concern is what's going on when x is 0. Okay, because if we think about the function of 1 over x, all right, if I do a quick graph over here, all right, here's our function's graph for 1 over x. Okay, and let me get out of the way there. So we're only interested in from -3 to 3. All right, so -3 somewhere around here. So we've got that region. All right, and then we're just going to 3. So we've got this region. Right? So some students will say, well, wait a minute, won't the positive region and the region below, rather, and the region above, won't they cancel each other out? Won't the answer be 0? All right, and the answer, unfortunately, is no. That's not the case. Okay, you actually have to work through this with the limits because we have to actually take into account what's going on when x is 0. Okay, because as x is approaching 0 from both the left and the right, our function is heading in an infinite manner. All right, so how do we handle this? Let me get this out of the way. Hold on a second. All right. So we've got to break this up, and the breaking point is at 0. All right, so if we were to rewrite this using our limit notation, we're going to have the limit as b approaches 0 from the left, all right, of the integral from -3 to b. All right, so we're starting at -3, and we're going to go all the way to 0, approaching from the left. Those are one-sided limits from much earlier in the year, all right, of our 1 over x dx. All right, and we need to, that takes care of the first part. Now we need to take care of the second part. Well, the second part is starting at 0, all right, so we want the limit as b approaches 0, but we want it from the right. Okay, so that should be a b down there, sorry. Okay, so now we're not starting at 0, we're starting at the values just to the right of 0, and we want to go all the way to 3 of 1 over x dx. Did I get that on the screen? Just barely. Okay, so we actually have to have two limits here because we have that unbounded behavior on both sides of 0. So the first integral and limit deals with the region to the left, and the second integral deals with the region to the right. Okay, so now if we want to see if there's an actual answer, then we have to calculate both of these limits. Right? So let's look at the first limit. Right? If we're doing the same thing that we did in the previous example. So we're going to have the limit as b approaches 0 from the left. Our antiderivative is the natural log of the absolute value of x, and that's being evaluated from -3 to b. Okay. So that means that we have, I know there's more over here, but just hold off on that for a second. The limit as b approaches 0 from the left of the natural log of b minus the natural log of the absolute value of -3, which means it'll end up being 3. Now the natural log of 3, that's a number, okay? But b's heading towards 0. And what do we know about natural log's value as we are approaching 0? Yeah, it is unbounded, all right? So we end up having infinity here, negative infinity if you want, minus its absolute value, minus the natural log of 3, all right? This is divergent, okay? So this region right here is divergent, so it actually doesn't even matter what happens over there, because if you're trying to add, even if this is a number, if you're trying to add a number to something that's already divergent, it's still going to be divergent. So this is an integral that overall will be divergent.